And here we are going to discuss the basic principle for neutralization. This is in page 2 of our notes. Now, first, so you should remember the definition of neutralization. This is a reaction between acid and base. The most important is to form salt and water only. This is the important equations because acid have many reactions, but only with base to form salt and water only. And here we introduce two types of reaction. Both of them involve acid, but the difference is one of them is soluble, one of them is insoluble base. For the soluble one, here we have a great example. React with sodium hydroxide to form sodium chloride and water. Now, you can see during the reaction, the base will contribute the cation and the acid will donate the anion to form the salt. And their ionic equation is simple. It's H plus react with hydroxide ion to form H2O. That's it. Because the salt is water soluble, so we will cancel it during the write down of ionic equation. The next one is the insoluble salt. Now here we have magnesium oxide or magnesium hydroxide as an example. Again, the base contribute the cation and the acid will donate the anion. So the product will be magnesium sulfate, which is AQ in both cases. Right, but how about the rest of them? Is H2O. For the second equation, so you should be careful. There are two H2O formed during the reaction because magnesium oxide or the base in this case are insoluble. This is no point for us to break it down into mobile ion, so we should keep it. But the sulfate ion can be cancelled out, so two hydroxide ion. So don't write anything like this. We don't have something like this. The magnesium ion keep and H2O. So you can see we balance the equation again here. And how about the second one? So again, the hydroxide ion cannot be cancelled out. It exists as a solid. And we got two hydrogen ion here to form magnesium ion and two H2O like this. So this will be the basic principle for neutralization. So you should complete the page 3, the checkpoint, and we will check the answer all together. And next, please turn to page 7. Now, with this short topic, we will introduce a new term called normal salt and acid salt. As we discussed before, the acid will contribute the anion and loss is hydrogen ion. So in this case, this is for dibasic or tribasic acid only. If all the hydrogen ion are replaced, they are called normal salt. Where we have plenty of choice. For example, sodium sulfate, sodium carbonate, etc., etc. All of them are from dibasic or tribasic acid, with all the hydrogen from the acid molecule replaced. But how about when only part of them are replaced? They are called acid salt. Again, we can have sodium hydrogen sulfate, or more familiar case is sodium hydrogen carbonate. So you can see only one of the hydrogen is replaced or removed from neutralization. And the equation is simple. We use sulfuric acid and potassium hydroxide as example. In case there is a normal salt, so you can see one sulfuric acid react with 2 potassium hydroxide and we get normal salt. What about if the mole ratio is 1:1, then only one hydrogen is removed? This is called acid salt. Now, so you can see this is no point for the monobasic acid to form acid salt. There will be, I shown the answer here. So you can see with sodium ion and the corresponding anion, the normal salt for monobasic acid will be shown like this. Well, this is the organic acid, so you can see we will put the anion in front, but this is not important. But what about the dibasic or tribasic acid? Then we can have many choice, and it is shown here. With dibasic acid, we can have one acid salt and one normal salt. But in case there is a tribasic acid, then we have 2 acid salts. And finally, here shows there is only acid salt formation when there is dibasic or tribasic acid.